Okay. So, you guys may not have used a lot of these unless you've used the pencil sharpener over here in my room, because lots of times we don't have those anymore. But I was going through an electric pencil sharpener. Now that thing's not great. Sometimes it's hateful, but I was going through an electric pencil sharpener like once a year. They would burn out every year. And that one's been there for like 6 or 7 years probably. So I'm a big fan of the classic pencil sharpener. There. Is it a little hateful? Sometimes, yes, it is. But I haven't had to throw it away yet. So the pencil sharpener here is on a level surface. Point B is located at the end of a handle that is 2 inches from the center of rotation. The handle rotates in a clockwise direction and completes 2 rotations every second. At time t equals 0 seconds, point B is located directly below the center of rotation. The center of rotation is 3 inches above the level surface on which the pencil sharpener sits. As the handle rotates, the distance between point B and the level surface periodically increases and decreases. And then it tells us about the sine function. What you are going to see on FRQ number 3 and the FRQs for your test on Thursday is you are going to have some sort of scenario. Probably one of them is probably going to be something going around in a circle, because things that go around in a circle behave periodically. So it's a really easy context to use. I'll probably try to make the other one that's not exactly a circle. We'll see some of those, like a pendulum or something, or a spring. We'll see those as well. So the sine function h models the distance in inches between point B and the level surface as a function of time t in seconds. The graph of h and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are presented. Determine possible coordinates T, H of T for the 5 points F, G, J, K, and P. So no matter what the scenario is, they don't change this part. This part right here is going to be the same, no matter what the prompt is. And the picture does not change. So the picture, F is going to be a maximum point, G is midline, J is minimum, K is midline, P is maximum. That stuff's staying the same no matter what the scenario is. So what we have to do is we have to sort of draw in the rest of the graph that we need, right? So I would start by probably looking for the starting point of this graph. I need to know at t equals 0, when time is 0, is my handle at the bottom, the middle, or the top? Right? It's going to be one of those 3. They won't give you anything other than those 3, right? So I'm looking for, because I need to know where to start from to even begin with this graph. So at time t equals 0, point B is located directly below the center of rotation. So is our point going to begin at a minimum, midline, or maximum? If point B is directly below center of rotation, that's the lowest point that point B is ever going to get, right? Whenever it's at the bottom, right? And then it'll go midline, top, midline, bottom, midline, top, midline, bottom, right? So, technically, you can use negative time for this, but it's not the best practice to do. Like, you wouldn't usually use that. So what I'm going to suggest, we need our graph to start at the bottom, right? But does this graph right here start at the bottom? It starts at the top, right? So I need to even draw out this a little bit further. And I'm going to extend this graph to a minimum point. So I'm going to add in this point. I'm also going to add in this point. Right? And my graph, I need it to start right there at the bottom. So I am going to put the y-axis right here. And they are not asking you for the coordinates of this point, but if they were, your x-coordinate is 0 right there. Now I need to figure out like what my y values are and where to put the x-axis on this graph. Okay, so this is my y-axis right here. So I see that I've got like, the only thing marked on this picture is that from like the center down here to B, this distance is 2 inches. But there's got to be more information here, because it talks about this flat surface that this is sitting on, right? And is the handle like touching that surface when it gets to its lowest point? It is not, right? Whenever the handle is at its lowest point, how far off of that flat surface, which is not very flat because I drew it badly, how far are we off of that flat surface? Well, actually, no. What does it tell you is 3 inches above the level surface? Center of rotation is 3 inches above. So actually, let me draw something else in here. The center down to the flat surface, that is 3 inches. So what I just drew right here, the lowest point, what is that going to be? 1 inch. And then as this handle rotates around, right, it'll hit a highest point up here. And that is also going to be another 2 inches above, right? So all of these are measured in the distance from the surface, right? The lowest is at 1. The middle is at 3. What's the highest that we go? 5, right? So 1, 3, and 5, that means my x-axis needs to be down here below any of these, right? X-axis goes here. And I'm going to put myself put yourself a little tick mark underneath every single point that you have. We'll worry about that x-axis a little bit more here in a second. Let's think about the y. So the lowest point that handle goes to is 1 inch above the ground. If it's in the middle, the center is at 3, and then 5 here. You should always make sure these are in order, right? 1, 3, 5. Don't put 5, 3, 1. That makes no sense for graphing things, right? And also make sure things are evenly spaced, right? Because if 3 is your midline, then the distance from 1 to 3 has to equal the distance from 3 to 5. If that's not, you can get some partial credit on this, like if you mess it up, but you have something feasible. But if you don't have evenly spaced increments here, or if your numbers are out of order, they're not going to give you any credit for those things. So you can go ahead and fill in all your y coordinates right now, because anything on this line has a y coordinate of 5. So F here has a y coordinate of 5, and P also has a y coordinate of 5. G has a y coordinate of 3, and K has a y coordinate of 3. They're both on that midline. And J has a y coordinate of 1. Now, our x coordinates, we got to think about what's happening. This x down here, this is your time, right? The time that you have, I believe, in seconds. Here, surely it's seconds. So, we're looking for information dealing with like the number of seconds for a rotation. What do you guys see that would help us up here? That's it. 2 rotations every second. Okay? So, if sometimes they'll give you the period of the graph, like they'll say 1 rotation in this many. They've actually given you frequency here, right? 2 rotations in 1 second. But for the period, you need to know 1 rotation in how many seconds. So how many seconds would it take for just 1 rotation? A half. Now, you can use decimals or fractions as long as they are correct. My suggestion is to go with fractions. I know that kids don't like fractions, that they see them and they panic. But your other option here, because you're going to have to split this up, right? This is 1 full period. You have to divide this by 4 to get what your tick marks are going to be, right? So 1 full period is going to be 1/2. You're going to have to divide that by 4. So 0.5 divided by 4. Anybody know that decimal like right off the top of your head? 0.5 divided by 4. Very good. You're welcome to use decimals because you got it. If everybody else knew it, that's fine too. I do not mind if you're using decimals as long as you're sure of them. I think fractions are a little bit easier here because if what you're going to do, whatever the period is, multiply it by 1/4. So that's going to give us 1/8. And those are your tick marks. Okay? Because this is set up where each little tick mark is going to be 1/4 of that rotation, right? So, so I'm going to use fractions, but you can use decimals as long as it is a decimal that you know how to do very easily. So this is going to be 1/8. Right, here's 0. This is, if you want, do 2 8s, 3 8s, 4 8s, 5 8s, 6 8s, and that's as far as we need to go. I do think they want the reduced fraction, so when I start filling these in, I'm going to leave it like this on my x-axis because I think that makes it so much easier to see, like what you're counting by, right? But right here, for F, my x-coordinate is 2 8s. Does 2 8s reduce? 1/4. So I'm going to write 1/4 here. I'm going to reduce it. At G, what is my x-coordinate? 3 8s. That does not reduce, so we're definitely leaving that one. Okay. What about at J? I've got 4 8s, but that can be reduced to 1/2. K is 5 8s. That will not reduce. And P is 6 8s. What does that reduce to? 3/4. I'm going to go double check that. I know they definitely prefer the reduced. I need to go double check and see if they'll take it if it's not reduced, because it is, you would hate to like make a mistake that's going to ruin you on that. So this is part A. It is worth 2 points because all FRQs are worth 6 points. This is worth 2 points. You get 1 point for getting the x coordinates right. You get 1 point for getting the y coordinates right. There. A lot of times when I grade, like let's say that you just like reduced 6 8s incorrectly and got 6/4 or something weird, you know, that's not right. I will usually give you some partial credit on that, but on the AP exam, they can't. It has to be all the x coordinates have to be right or all the y coordinates have to be right. So you got to have them all right to get full credit. And I think I'm going to go back and look at the scoring rubrics on these. I think there is like a stipulation that if you do something like so bad, like you had 5 3, 1 here, like you put those out of order, that you just get no credit. Like even if you have your x coordinates right, because you've done some terrible things there for that. Okay, now we've done problems like part B, where they're asking you to write the equation. We have not done any yet where we had to come up with the points on our own, but that's what you're going to have to do on that free response. You got to get those points on your own. Now, maybe it's part B where you can't get any credit. If you do something so crazy it makes absolutely no sense, like you don't have your y coordinates spaced evenly, I think it's part B where you just can't get any points. So you can have your graph wrong and still get part B right, as long as you haven't done anything just so crazy. All of your x coordinates have to be evenly spaced. Your y coordinates have to be evenly spaced. You can't have like just ridiculous things there that you couldn't write an equation for. All right, so we've got to find A, B, C, and D. They will tell you on part B. For part B, the question will always look like this. The only thing that might change is they may give you sine or they may give you cosine. Okay, so part B wording is always going to be the same, but they might give you sine or they might give you cosine. In this case, they have given us sine. So what I would suggest is to go over here. Sine, where does sine have a y-intercept? At midline, maximum, minimum, which one is it? Midline. So sine would be midline, maximum, midline, minimum, midline. And so sine, I'm just going to draw a dotted line here. If you do draw this in, make sure you use a dotted line so it's pretty clear you know it's not the real graph. Plus it helps you differentiate which ones needs to move. So they've told us we have to use sine. We've got to find A, B, C, and D. So A, B, C, and D. I think A and D are the easiest to find. Braden, what is A going to be for this one? 2. And Zane, what about D? 3. Right, amplitude is A. Midline is D. Now we could go back and make A negative later if we want. Is it really going to help us to flip this graph on this problem? I wouldn't say so, because even if you do flip it, you're still going to have to do a shift, so don't overcomplicate it. However, sometimes you can just flip the graph and you don't have to do a phase shift, and I would suggest doing that if it's a possibility. So now I need B and C. Really doesn't matter which one you do first here. For those, I think I'll do C first. You need to think about taking your dotted line right here and moving it over to your solid line. Dotted always gets moved to solid, right? And I have to move this essentially 1 tick mark, right? How far is 1 tick mark? 1/8 for this problem, right? So, and should it be positive 1/8 or negative 1/8? Negative, you have to use the opposite sign, because we are taking, remember, always dotted to solid, right? So we are moving that dotted line to the right 1/8, so we have to put a negative 1/8 here. And our last part for the B, the period of this graph we already said was 1/2, right? So if we do 2 pi over B equals 1/2, you can cross multiply right here. B times 1 is B. 2 pi times 2 is 4 pi. So 4 pi is your B value. Okay, questions? Okay, that part's worth 2 points. A and D get you 1 point. B and C get you 1 point. A lot of times, if you like get A and C, I'll give you 1 point. Technically, on the actual AP exam, they won't do that. But usually, if you're going to get some right, you get A and D right. Those are usually a lot easier to find than the middle two. Okay, now, C is always going to be the same. However, hold on just a second. Let me go look. I think the wording on this has changed a little. This is what that second question is going to look like. I think the first year that they gave it, they were getting bad answers on that. Kids weren't being specific enough, even though they were correct. So, this last part is going to be the same. They really put a multiple choice question in the free response question part, is what they have done. They're going to say, refer to the graph of H in part A. The t-coordinate of J is T1, and the t-coordinate of K is T2. The only thing that is going to change about what this looks like is the J and the K. So they are going to give you two letters that come from the graph above. They will be two letters that are next to each other. Okay? So when they give us this, we got the t-coordinate of J and the t-coordinate of K. We need to go to the graph and look at that segment of the graph. Okay, that piece of the graph. So, if I go up here, well, I told you guys to fix that, and I haven't given you time to do it, have I? If I go up here to J to K, we're talking about this piece of the graph. Okay, so we're going to go look at that part, and then we are supposed to tell whether the graph is positive and increasing, positive and decreasing, negative and increasing, negative and decreasing. Positive means above x-axis. Negative means below x-axis. Is any of our graph below the x-axis for this problem? No. So C and D are out. So it depends on where that x-axis is falling. Sometimes it's right there at the midline. Sometimes it's up above the graph. It just depends on the situation. Is my function increasing or decreasing from J to K? What? Increasing. So A is our answer. Okay. You can answer this part right even if you totally butchered the rest of the question, right? Because that graph doesn't change. So if they ask you from J to K, I guess you do kind of have to know, I guess your Y values have to be right. You have to know where the x-axis is on this. But as long as you have, like, whether or not those Y coordinates are positive or negative, you can get this part right here. And the reason they're giving you all this T1, T2 is because for this to be an interval, those have to be like the values from your x-axis. Those have to be the domain values. It's really not all that important. You don't have to pay a lot of attention to what those T1 and T2 values are. It's just the domain. In this case, it'd be 1/2 to 5/8 is the interval that you're looking at. But if you look from J to K, you'll be okay there. Then part 2 is going to say on the interval T1, T2, describe the concavity of the graph of H and determine whether the rate of change of H is increasing or decreasing. Okay, so if I look at that graph, is my graph concave up or concave down from J to K? Concave up. So we are going to word our answer this way. On the interval, T1 to T2. You need to put that because this graph is not concave up everywhere. It's concave up here, right? So on the interval, T1 to T2, the graph of H is concave up. the rate of change of h is, we got to tell whether the rate of change of h is increasing or decreasing. Rate of change is like the slope of the line, right? So, two ways to think about this. First way would be to think about drawing in some little tangent lines. Like here, this tangent line's flat. And here we would have this. And here we would have this. And here we would have this. Now, we're not seeing a great change, but this would be like a slope of 0, right? Is my slope increasing or decreasing with those little tangent lines? Increasing, right? And we got positive numbers, so maybe this is 1, maybe this is 1.5, maybe this is 2. I'm making things up. Those probably aren't right, but we definitely have increasing numbers. So we could say rate of change of h is increasing. On this interval. Okay. Yes. I would not, because when you're talking about an interval, you are supposed to use x coordinates only. So that t1 to t2, those are the x coordinates. So like, normally they'd be numbers, right? So you're given like from 7 to 11, right? Or in this case, from 1/2 to 5/8, or 1/4 to 5/8. No, 1/2 to 5/8 was right. So I would just use their wording, right? So you don't have to put numbers in here. You're thinking J to K, but I would use their wording for this. For that. The other thing you can think about here is that if you know the concavity, you also know the rate of change is increasing or decreasing. Because remember we made, like, way back when, we said if we know the graph of h is this, we know that the rate of change of h is this, right? And we said if h is increasing, then the rate of change of h is positive. And if h is decreasing, the rate of change of h is negative. But are they asking us if the rate of change of h is positive or negative? They are not. What they want to know is if rate of change of h is increasing or decreasing. And that's going to tell us concavity. So if the rate of change of h is increasing, h is concave up. And if the rate of change of h is decreasing, we've got concave down. For that. So, if you get concave up, you have to get increasing, right? Concave up always goes with increasing. If you get concave down, the rate of change of h is decreasing. That's always going to be the case. You won't see it be anything other than that. Okay, questions? All right, we spent a lot of time going through that because I want to make sure we're understanding